Welcome to Pig Tutorial. My name is Richard Kirschner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. If you have questions during the tutorial or want added reference, please note you can post in the YouTube notes section below. We do have people monitoring the YouTube channel. Or come visit us at our website, www.simplilearn.com. What's in it for you? Let's get started with Pig. Why Pig? What is Pig? MapReduce versus Hive versus Pig. Hopefully you've had a chance to do our Hive tutorial and our MapReduce tutorial. If you haven't, send a note over to Simplilearn and we'll follow up with a link to you. We'll look at Pig architecture, working of Pig, Pig Latin data model, Pig execution modes, a use case Twitter, and features of Pig. And then we'll tag on a short demo so you can see Pig in action. So, why Pig? As we all know, Hadoop uses MapReduce to analyze and process big data. Processing big data consumed more time. So before we had the Hadoop system, they'd have to expend a lot of money on a huge set of computers and enterprise machines. So he introduced the Hadoop MapReduce. And so afterwards, processing big data was faster using MapReduce. Then what is the problem with MapReduce? Prior to 2006, all MapReduce programs were written in Java. Non-programmers found it difficult to write lengthy Java codes. They faced issues in incorporating map, sort, reduce to fundamentals of MapReduce while creating a program. You can see here map phase, shuffle, and sort reduce phase. Eventually, it became a difficult task to maintain and optimize the code, due to which the processing time increased. You can imagine a manager trying to go in there and needing a simple query to find out data, and he has to go talk to the programmers anytime he wants anything. So that was a big problem. Not everybody wants to have an on-call programmer for every manager on their team. Yahoo faced problems to process and analyze large data sets using Java, as the codes were complex and lengthy. There was a necessity to develop an easier way to analyze large data sets without using time-consuming complex Java modes and codes and scripts and all that fun stuff. Apache Pig was developed by Yahoo. It was developed with the vision to analyze and process large data sets without using complex Java codes. Pig was developed especially for non-programmers. Pig used simple steps to analyze data sets, which was time efficient. So what exactly is Pig? Pig is a scripting platform that runs on Hadoop clusters designed to process and analyze large data sets. And so you have your Pig, which uses SQL-like queries. They're definitely not SQL, but some of them resemble SQL queries. And then we use that to analyze our data. Pig operates on various types of data like structured, semi-structured, and unstructured data. Let's take a closer look at MapReduce versus Hive versus Pig. So we start with a compiled language, your MapReduce. And we have Hive, which is your SQL-like query. And then we have Pig, which is a scripting language. It has some similarities to SQL, but it has a lot of its own stuff. Remember, SQL-like query, which is what Hive is based off, looks for structured data. And so when we get into scripting languages like Pig, now we're dealing more with semi-structured and even unstructured data. With a Hadoop MapReduce, we have a need to write long, complex codes. With Hive, no need to write complex codes. You could just put it in a simple SQL query or HQL, HiveQL. And in Pig, no need to write complex codes, as we have Pig Latin. Now remember, in the MapReduce, it can produce structured, semi-structured, and unstructured data. And as I mentioned before, Hive can process only structured data. Think rows and columns. Where Pig can process structured, semi-structured, and unstructured data. You can think of structured data as rows and columns, semi-structured as your HTML, XML documents like you have on your web pages, and unstructured could be anything from groups of documents and written format, Twitter, tweets, any of those things come in as very unstructured data. And with our Hadoop MapReduce, we have a lower level of abstraction. With both Hive and Pig, we have a higher level abstraction. So it's much more easy for someone to use without having to dive in deep and write a very lengthy MapReduce code. And those map and reduce codes can take 70, 80 lines of code when you can do the same thing in 1 or 2 lines with Hive or Pig. This is the advantage Pig has over Hive. It can process only structured data in Hive, while in Pig it can process structured, semi-structured, and unstructured data. Some other features to note that separates the different query languages is when we look at map and reduce, MapReduce supports partitioning features, as does Hive. Pig, no concept of partitioning in Pig, so it doesn't support your partitioning feature. Your partitioning features allow you to partition the data in such a way that it can be queried quicker. You're not able to do that in Pig. MapReduce uses Java and Python, while Hive uses an SQL-like query language known as HiveQL or HQL. Pig Latin is used, which is a procedural data flow language. MapReduce is used by programmers, pretty much as straightforward on Java. Hive is used by data analysts. Pig is used by researchers and programmers. Certainly there's a lot of mix between all three. Programmers have been known to go in and use a Hive for a quick query, and anybody's been able to use Pig for a quick query or research. Under Map and Reduce, code performance is really good. Under Hive, code performance is lesser than Map and Reduce in Pig. Under Pig, code performance is lesser than MapReduce, but better than Hive. So if we're going to look at speed and time, the MapReduce is going to be the fastest performance on all of those, where Pig will have second and Hive follows in the back. Let's look at components of Pig. Pig has two main components. We have Pig Latin. Pig Latin is the procedural data flow language used in Pig to analyze data. It is easy to program using Pig Latin. It is similar to SQL. And then we have the runtime engine. Runtime engine represents the execution environment created to run Pig Latin programs. It is also a compiler that produces MapReduce programs. It uses HDFS, or your Hadoop file system, for storing and retrieving data. And as we dig deeper into the Pig architecture, we'll see that we have Pig Latin scripts. Programmers write a script in Pig Latin to analyze data using Pig. Then you have the grunt shell, and it actually says grunt when we start it up, and we'll show you that here in a little bit, which goes into the Pig server, and this is where we have our parser. Parser checks the syntax of the Pig script. After checking the output will be a DAG, directed acyclic graph. And then we have an optimizer, which optimizes after your DAG, your logical plan is passed to the logical optimizer where an optimization takes place. Finally, the compiler converts the DAG into MapReduce jobs, and then that is executed on the MapReduce under the execution engine. The results are displayed using dump statement and stored in HDFS using store statement. And again, we'll show you that. They kind of end, you always want to execute everything once you've created it, and so dump is kind of our execution statement. And you can see right here, as we were talking about earlier, once we get to the execution engine and it's coded into MapReduce, then the MapReduce processes it onto the HDFS. Working of Pig. Pig Latin script is written by the users. So you have load data and write Pig script and Pig operations. So when we look at the working of Pig, Pig Latin script is written by the users. There's step one. We load data and write Pig script. And step two, in this step, all the Pig operations are performed by parser, optimizer, and compiler. So we go into the Pig operations. And then we get to step three, execution of the plan. In this stage, the results are shown on the screen, otherwise stored in the HDFS as per the code. So it might be you have a small amount of data you're reducing it to and you want to put that on the screen, or you might be converting a huge amount of data which you want to put back into the Hadoop file system for other use. Let's take a look at the Pig Latin data model. The data model of Pig Latin helps Pig to handle various types of data. For example, we have Atom, Rob, or 50. Atom represents any single value of primitive data type in Pig Latin, like integer, float, string. It is stored as a string. Tuple, so we go from our atom, which are our most basic thing. So if you look at just Rob or just 50, that's an atom. That's our most basic object we have in Pig Latin. Then you have a tuple. Tuple represents sequence of fields that can be of any data type. It is the same as a row in RDBMS. For example, a set of data from a single row. And you can see here we have Rob, 5. And you can imagine with many of our other examples we've used, you might have the ID number, the name, where they live, their age, their date of starting the job. That would all be one row and stored as a tuple. And then we create a bag. A bag is a collection of tuples. It is the same as a table in RDBMS and is represented by brackets. And you can see here we have our table with Rob 5, Mike 10. And we also have a map. A map is a set of key value pairs. Key is of character array type and a value can be of any type. It is represented by the brackets. And so we have name and age, where the key value is Mike and 10. Pig Latin has a fully nestable data model. That means one data type can be nested within another. Here's a diagram representation of Pig Latin data model. And in this particular example, we have basically an ID number, a name, an age, and a place. And when we break this apart, we look at this model from Pig Latin perspective. We start with our field. And if you remember, a field contains basically an atom. It is one particular data type. And the atom is stored as a string, which it then converts it into either an integer, or number, or character string. Next we have our tuple, and in this case you can see that it represents a row. So our tuple would be 3, Joe, 29, California. And finally we have our bag, which contains 3 rows in it in this particular example. Let's take a quick look at Pig execution modes. Pig works in 2 execution modes, depending on where the data is residing and where the Pig script is going to run. We have local mode. Here the Pig engine takes input from the Linux file system and the output is stored in the same file system. Local mode is useful in analyzing small data sets using Pig. And we have the MapReduce mode. Here the Pig engine directly interacts and executes in HDFS and MapReduce. In the MapReduce mode, queries written in Pig Latin are translated into MapReduce jobs and are run on a Hadoop cluster. By default, Pig runs in this mode. There are 3 modes in Pig, depending on how a Pig Latin code can be written. We have our interactive mode, batch mode, and embedded mode. The interactive mode means coding and executing the script line by line. When we do our example, we'll be in the interactive mode. In batch mode, all scripts are coded in a file with the extension .pig, and the file is directly executed. And then there's embedded mode. Pig lets its users define their own functions, UDFSs, in a programming language such as Java. So let's take a look and see how this works in a use case. In this case, use case Twitter. Users on Twitter generate about 500 million tweets on a daily basis. The Hadoop MapReduce was used to process and analyze this data. Analyzing the number of tweets created by a user in the tweet table was done using MapReduce in Java programming language. And you can see the problem. It was difficult to perform MapReduce operations as users were not well versed with written complex Java codes. So Twitter used Apache Pig to overcome these problems. And let's see how. Let's start with the problem statement. Analyze the user table and tweet table and find out how many tweets are created by a person. And here you can see we have a user table. We have Alice, Tim, and John with their ID numbers 1, 2, 3, and we have a tweet table. In the tweet table you have your the ID of the user and then what they tweeted. Google was a good whatever it was, tennis, spacecraft, Olympics, politics, whatever they're tweeting about. The following operations were performed for analyze the given data. First, the Twitter data is loaded into the Pig storage using load command. And you can see here we have our data coming in and then that's going into Pig storage. And this data is probably on an enterprise computer. So this is actually active Twitters going on and then it goes into Hadoop file system. Remember, the Hadoop file system is a data warehouse for storing data. And so the first step is we want to go ahead and load it into the Pig storage, into our data storage system. The remaining operations performed are shown below. In join and group operation, the tweet and user tables are joined and grouped using cogroup command. And you can see here where we add a whole column when we go from usernames and tweet to the ID linked directly to the name. So Alice was user 1, Tim was 2, and John 3. And so now they're listed with their actual tweet. The next operation is the aggregation. The tweets are counted according to the names. The command used is count. So it's very straightforward. We just want to count how many tweets each user is doing. And finally, the result after the count operation is joined with the user table to find out the username. And you can see here where Alice had 3, Tim 2, and John 1. Pig reduces the complexity of the operations, which would have been lengthy using MapReduce. In join and group operation, the tweet and user tables are joined and grouped using cogroup command. The next operation is the aggregation. The tweets are counted according to the names. The command used is count. The result after the count operation is joined with the user table to find out the username. And you can see we're talking about 3 lines of script versus a MapReduce code of about 80 lines. Finally, we could find out the number of tweets created by a user in a simple way. So let's go quickly over some of the features of Pig that we already went through most of these. First, ease of programming, as Pig Latin is similar to SQL. Lesser lines of code need to be written. Short development time as the code is simpler, so we can get our queries out rather quickly instead of having to have a programmer spend hours on it. Handles all kind of data like structured, semi-structured, and unstructured. Pig lets us create user-defined functions. Pig offers a large set of operators such as join, filter, and so on. It allows for multiple queries to process in parallel, and optimization and compilation is easy as it is done automatically and internally. So enough theory. Let's dive in and show you a quick demo on some of the commands you can do in Pig. Today's setup will continue as we have in the last 3 demos to go ahead and use Cloudera Quick Start. And we'll be doing this in VirtualBox. We do have a tutorial in setting that up. You can send a note to our Simplilearn team and then get that link to you. Once your Cloudera Quick Start has spun up, and remember this is VirtualBox. We've created a virtual machine, and this virtual machine is CentOS Linux. Once it's spun up, you'll be in a full Linux system here. And as you can see, we have Thunderbird browser, which opens up to the Hadoop Basic System browser. And we can go underneath the Hue, where it comes up by default. If you click on the pull-down menu and go under Editor, you can see there's our Impala, our Hive, Pig, along with a bunch of other query languages you can use. And we're going under Pig. And then once you're in Pig, we can go ahead and use our command line here and just click that little blue button to start it up and running. We will actually be working in terminal window. And so if you're in the Cloudera Quick Start, you can open up the terminal window up top, or if you're in your own setup and you're logged in, you can easily use all of your commands here in terminal window. And we'll zoom in. That way you get a nice view of what's going on. There we go. Now for our first command, we're going to go ahead and do a Hadoop command and import some data into the Hadoop system, in this case a Pig input. And let's just take a look at this. We have Hadoop. Now let's know it's going to be a Hadoop command. DFS. There's actually 4 variations of DFS. So if you have HDFS or whatever, that's fine. All 4 of them used to be different setups underneath different things, and now they all do the same thing. And we want to put this file, which in this case is under Home Cloudera Documents and Sample, and we just want to take that and put it into the Pig input. And let's take a look at that file. If I go under my document browsers and open this up, you'll see it's got a simple ID, name, profession, and age. We have one Jack Engineer 25, and that was in one of our earlier things we had in there. And so let's go ahead and hit enter and execute this, and now we've uploaded that data and it's gone into our Pig input. And then a lot of the Hadoop commands mimic the Linux commands, and so you'll see we have cat as one of our commands, or it has a hyphen before it. So we execute that with Hadoop DFS -cat /pig input, because that's what we called it. That's where we put our sample CSV at. And we execute this. You can see from our Hadoop system, it's going to go in and pull that up, and sure enough, it pulls out the data file we just put in there. And then we can simply enter the Pig Latin or Pig editor mode by typing in Pig. And we can see here by our grunt, I told you that's how it was going to tell you were in Pig Latin. There's our grunt command line. So we are now in the Pig shell. And then we'll go ahead and put our load command in here. And the way this works is I'm going to have office equals load. And here's my load. In this case, it's going to be Pig input. We have that in single brackets. You remember that's where the data is in the Hadoop file system where we dumped it into there. We're going to be using Pig storage. Our data was separated as with a comma. So there's our comma separator. And then we have as. And in this case, we have an ID, character array, name, character array, profession, character array, and age, character array. And we're just going to do them all as character arrays just to keep this simple for this one. And then when I hit put this all in here, you can see that's our full command line going in, and we have our semicolon at the end. So when I hit enter, it's now set office up. But it hasn't actually done anything yet. It doesn't do anything until we do dump office. So there's our command to execute whatever we've loaded or whatever setup we have in here. And we run that, you can see it go through the different languages, and this is going through the MapReduce. Remember, we're not doing this locally, we're doing this on the Hadoop setup. And once we finished our dump, you can see we have ID, name, profession, age, and all the information that we just dumped into our Pig. We can now do, let's say we have a request just for, we'll keep it simple in here, but just for the name and age. And so we can go office, we'll call it each as our variable, underscore each, and we'll say for each office, generate name, comma, age. And for each means that we're going to do this for each row. And if you're thinking map reduce, you know that this is a map function because it's mapping each row and generating name and age on here. And of course, we want to go ahead and close it with a semicolon. And then once we've created our query or the command line in here, let's go ahead and dump office underscore each, in with our semicolon, and this will go through our MapReduce setup on here. And if we were on a large cluster, the same processing time would happen. In fact, it's really slow because I have multiple things on this computer, and this particular virtual box is only using a quarter of my processor. It's only dedicated to this. And you can see here, there it is, name and age. And it also included the top row since we didn't delete that out of there or tell it not to. And that's fine for this example, but you need to be aware of those things when you're processing a significantly large amount of data or any data. And we can also do Office, and we'll call this DSC for descending. So maybe the boss comes to you and says, hey, can we order Office by ID descending? And of course your boss, you've taught him how to, your shareholder, it sounds a little derogatory when I say boss. You've talked to the shareholder and you said, and you've taught them a little bit of Pig Latin, and they know that they can now create Office description, and we can order Office by ID description. And of course once we do that, we have to dump Office underscore description so that it'll actually execute, and there goes into our MapReduce. It'll take just a moment for it to come up because again I'm running on only a quarter of my processor, and you can see we now have our IDs in descending order returned. Let's also look at, and this is so important with anytime you're dealing with big data, let's create Office with a limit. And you could of course do any of this instead of with Office. We could do this with Office descending, so you get just the top 2 IDs on there. But we're going to limit just to 2, and of course to execute that we have to dump Office underscore limit. And you can just think of dumping your garbage into the pig pen for the pig to eat. There we go, dump Office limit 2, and that's going to just limit our Office to the top 2. And for our output we get our first row, which had our ID, name, profession, and age, and our second row, which is Jack, who's an engineer. And let's do a filter. We'll call it Office underscore filter. You guessed it, equals filter Office by profession equals, and keep note this is similar to how Python does it with the double equal signs for equal for doing a true false statement. So for your logic statement, remember to use 2 equal signs in pig, and we're going to say it equals doctor. So we want to find out how many doctors do we have on our list. And we'll go ahead and do our dump. We're dumping all our garbage into the pig pen, and we're letting pig take over and see what it can find out and see who's a doctor on our list. And we find employee ID number 2, Bob is a doctor, 30 years old. For this next section, we're going to cover something we see a lot nowadays in data analysis, and that's word counting, tokenization. That is one of the next big steps as we move forward in our data analysis, where we go from, say, stock market analysis of highs and lows and all the numbers to what are people saying about companies on Twitter? What are they saying on the web pages and on Facebook? Suddenly you need to start counting words and finding out how many words are total, how many are in the first part of the document, and so on. We're going to cover a very basic word count example. And in this case, I've created a document called wordrows.txt. And you can see here we have Simplilearn is a company supporting online learning. Simplilearn helps people attain their certifications. Simplilearn is an online community. I love Simplilearn. I love programming. I love data analysis. And I went and saved this into my documents folder so we could use it. And let me go ahead and open up a new terminal window for our word count. Let me go ahead and close the old one. So we're going to go in here, and instead of doing this as pig, we're going to do pig -x local. And what I'm doing is I'm telling the pig to start the pig shell, but we're going to be looking at files local to our virtual box or this CentOS machine. And let me go ahead and hit enter on there. Just maximize this up. There we go. And it'll load pig up, and it's going to look just the same as the pig we were doing, which was defaulted to our Hadoop system, to our HDFS. This is now defaulted to the local system. And now we're going to create lines, and we're going to load it straight from the file. Remember last time we took the HDFS and loaded it into there and then loaded it into pig. Since we're on the local, we're just going to run a local script. We have lines equals load home, the actual full path, home, Cloudera, documents, and I called it wordrows.txt. And as line is a character array, so each line, and you can change this to read each document. I certainly have done a lot of document analysis, and then you go through and do word counts and different kind of counts in there. So once we go ahead and create our line, instead of doing the dump, we're going to go ahead and start entering all of our different setups for each of our steps we want to go through. And let's just take a look at this next one, because the load is straightforward. We're loading from this particular file. Since we're local, it's loading it directly from here instead of going into the Hadoop file system. And it says as, and then each line is read as a character array. Now we're going to do words equal for each of the lines, generate flat tokenize line space as word. Now there's a lot of ways to do this. This is if you're a programmer, you're just splitting the line up by spaces. There's actual ways to tokenize it. You gotta look for periods, capitalization. There's all kinds of other things you play with this. But for the most basic word count, we're just going to separate it by spaces. The flatten takes the line and just creates it flattens each of the words out. So this is, we're just going to generate a bunch of words for each line. And then each of those words is as a word. A little confusing in there, but if you really think about it, we're just going down each line, separating it out, and we're generating a list of words. One thing to note is the default for tokenize. You can just do tokenize line without the space in there. If you do that, it'll automatically tokenize it by space. You can do either one. And then we're going to do group. We're going to group it by words. So we're going to group words by word. So when we split it up, each token is a word and it's a list of words. And so we're going to grouped equals group words by word. So we're going to group all the same words together. And if we're going to group them, then we want to go ahead and count them. And so for count, we'll go ahead and create a word count variable. And here's our for each. So for each grouped is our line where we group all the words in the line that are similar. We're going to generate a group. And then we're going to count the words. For each grouped, so for each line where we group the words together, we're going to generate a group, and that's going to count the words. So we want to know the word count in each of those. And that comes back in our word count. And finally, we want to take this and we want to go ahead and dump word count. And this is a little bit more what you see when you start looking at grunt scripts. You'll see right here, these lines right here, we have each of the steps you take to get there. So we load our file. For each of our lines, we're going to generate and tokenize it into words. Then we're going to take the words and we're going to group them by same words. For each grouped, we're going to generate a group and we're just going to count the words. So we're going to summarize all the words in here. And let's go ahead and do our dump word count, which executes all this. And it goes through our MapReduce. It's actually a local runner. You'll see down here, you start seeing where they still have MapReduce, but it's a special runner. We're mapping it. That's a part of each row being counted and grouped. And then when we do the word count, that's the reducer. The reducer creates these keys. And you can see I is used 3 times, A came up once, and came up once, is 2. You can continue on down here to attain, online, people, company, analysis. Simplilearn, they took the top rating with 4. Certification. So all these things are then counted in the how many words are used. And in data analysis, this is probably the beginnings of data analysis, where you might look at it and say, oh, they mentioned love 3 times. So whatever's going on in this post, it's about love. And what do they love? And then you might attach that to the different objects in here. So you can see that Pig Latin is fairly easy to use. There's nothing really, it takes a little bit to learn the script. Depending on how good your memory is. As I get older, my memory leaks a little bit more, so I don't memorize it as much. But that was pretty straightforward, the script we put in there. And then it goes through the full map, reduce, localized, run, comes out. And like I said, it's very easy to use. That's why people like Pig Latin, is because it's intuitive. One of the things I like about Pig Latin is when I'm troubleshooting. When we're troubleshooting, a lot of times you're working with a small amount of data and you start doing one line at a time. And so I can go lines equal load, and there's my loaded text, and maybe I'll just dump lines. And then it's going to run, it's going to show me all the lines that I'm working on in this small amount of data. And that way I can test that. If I got an error on there that said, oh, this isn't working, maybe I'll be like, oh my gosh, I'm in MapReduce, or I'm in the basic grunt shell instead of the local path grunt. So maybe it'll generate an error on there. And you can see here it just shows each of the lines going down. So just a quick recap. We went over some key takeaways. Why Pig? Because MapReduce was very expensive in production for some of the for running basic queries and analysis. So Pig, easy to use, easy to learn. We looked at MapReduce versus Hive versus Pig. We found out that there's a lot of differences, like Hadoop and Hive can both partition. Hive and Pig came out because running the MapReduce in Java and 80 lines of code was more than anybody really wanted to put in on a basic query. Imagine you're the shareholder and they come back and they say, yes, we can answer that question, which you need so that you can ask the next question, but it's going to take a day because our programmer has to get to it. He's stacked. This way, you could actually just go in and write your own SQL code. You can go in there and write your own Pig Latin. We went over the Pig architecture and how that all fits together with the Grud shell versus the Pig server, the parser, the optimizer, compiler, execution engine into MapReduce, and the HDFS. We looked over Pig Latin data model, where we learned about the atom, which is your most basic data type. And then you have your tuple, which is like a collection. In this case, we looked at a tuple as a row, where we tokenized it into a single tuple. Then you have your bag, which is a group of tuples. And finally, you can do map also in there. We start mapping that data across. We looked at the use case for Twitter, and we looked at features of Pig. And then finally we did a quick demo so you could see some hands-on there with what it's like to pull data using Pig Latin. I want to thank you for joining us for Pig. For more information, visit www.simplylearn.com. My name is Richard Kirschner. I look forward to seeing you in our classes, or if you have questions, come visit us or post below in the YouTube video as we do monitor those posts.
Hi there, if you like this video, subscribe to the Simply Learn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.